Quiz on probability and statistics. So, number one. So, a coffee shop offers small, medium, and large sizes. Customers can choose between French roast, Italian roast, and American roast. So, essentially, guys, this is the counting principle. So, you guys count, well, there is three different sizes. So, three. And then customer can choose between three different rows. So that'd be 3 times 3. So that's a total of 9 possible outcomes. So that one, you guys, would be A. Number 2. 2 rooms in a house need to be painted. So 2 rooms need to be painted. Each room can be painted either white or yellow. So that's another 2 cases. So 2 times 2, which would give us 4. All right. So remember, this is just your guys' counting principle. Number 3. So in this problem, you guys have a spinner that can land on either red, blue, green, or yellow or purple. So red, blue, green, yellow, or purple. That's around to be 5, right? About 5. So 5. And you flip a coin. So flip a coin and then the spinner. So 5 total for spinning. How many options for flipping a coin? 2. So 5 times 2, which is going to give you 10. Okay. Moving on. Okay, so we have 4. So for number 4, you guys, it says a softball player bats 4 times in a game. Each at bat results in an out, getting on base, or hitting a home run. So basically, if there is a person that hits 4 times, right? That's at bat 4 times. Well, how many options is the first scenario? How many outcomes? 3. How many for the second? 3. How many for the next? 3. How many for the next? 3. Because each time they go at bat, they can get an out, get on base, or hit a home run. So it's 3 to the 4th, which is simply 81. So there's that, you guys. All right, number 5. Now, when you guys do number 5, so let's read. A new car is available, and a sedan model and a hatchback model. So that's 2 different types of models, so I'm going to write 2. It is available in 6 different colors, so I'm going to multiply by 6 because there's 6 color options. Now here's a part where it gets a little tricky, but you guys just have to view it in this manner. Customers can choose to add any combination of 4 optional features. So kind of imagine like this, you guys. If you say yes or no, you can say yes or no to each feature. So essentially, well, if there's feature 1, feature 2, feature 3, and feature 4, you can say yes or no, which means there's 2 options here. You can say yes or no to option 2, so that's also 2. You can say yes or no to option 3, which is 2 options, and you can say yes or no to option 4, which is also 2 options. So you're going to be multiplying by 2 to the 4th, because each option you can say yes or no, which means there's 2 outcomes for each option. So multiply all those together, and you guys should have gotten 192. All right, number 6. Okay, a spinner can land on either red or blue. You spin 6 times and then roll 6-sided die. So the spinner, either red or blue, and you spin it 6 times. So that's going to be 2 to the 6. 2 representing the spinner has 2 colors. The 6 because you spin it 6 times. And then multiply by what are the amount of outcomes from rolling a 6-sided die? There's 6 options. So 2 to the 6 times 6, and I believe that is 384. Okay, so that's number 6. Number 7. Okay, so make sure you guys look at those other YouTube videos as well, because some of you guys have TI-30X for your graphing calculator or scientific calculator. Some of you guys have Casio, or some of you guys have a graphing calculator. So definitely look at those YouTubes to get this notation right here. You're going to be using that notation. Or you're going to be using this notation depending on if order matters or not. This is the one, you guys. Order does not matter. And permutation is where order matters. Just a recap on that. Okay, so 5 out of 10 students will ride in a car instead of a van. Well, there's no order or any specifics about it. So this one's gonna be combination. So 10 students, and you choose 5 of them. So 10 choose 5, you guys, and when you guys put this into your calculator, what you should have gotten is 252, which would be C. So it's going to be a combination. 8. JD has homework assignments in 7 subjects. She only has time to do 4 of them. Well, she only has time to do 4 of them, but it doesn't say specifically which 4, right? So this one's going to be combination. So 7 total subjects, and you're choosing 4 of them. So 7 choose 4. So in your guys' calculator, gotta do 7 choose 4, and you should have gotten that this is 35. 35, which is A. Okay. Moving on to 9. Okay, Carlos has homework in 4 subjects. He is deciding what order to complete them in. So, this one, you guys, is talking about an order. So, because of that, and he has 4 subjects. So, 4 out of 4 subjects, you choose 4 of them. So, as a result, this is permutation. So, 4 choose 4 for permutation, and you should have gotten 24. Order does matter for this one. That's how you know it's permutation. Okay, 10. A team of 16 lacrosse players need to choose 2 players to refill the water cooler. So any 2 players, right, have the 16. So order doesn't matter for that. So it's going to be combination. So 16. And you're choosing 2 of the players. So 16 choose 2. And what you guys should have gotten is 120. And that is B. 11. A group of 20 people are going to run a race. The top 3 runners earn gold, silver, and bronze. So that is specifically in order, right? There's a gold person, a silver, and a bronze. So this is going to be permutation. So 20, and you're choosing 3 of them. So once you guys put this into your calculator, what you should have gotten is 6,840, and that is C, 6,840 permutation. 12. 190 students want to elect a president, so I automatically know it's permutation because there's an order. It has to be a president, vice president, and a secretary. and you're choosing 3 of them. So in your calculators, 190, and you're choosing 3 of them, and you guys should have gotten 6,751,080, which is B. Alright, so now we're going to get into the word problems, okay? Alright. A child is drawing a rainbow using a box of 10 different colored crayons, okay? Which include 7 required colors. After the red, orange, yellow, and green arcs in the proper order, he forgets the last 3 colors. From the remaining 6 crayons, he chooses 3 at random to finish drawing the rainbow. What is the probability that he correctly finishes the ROYGBIV rainbow? Okay, so they already picked out red, orange, yellow, and green, right? So you guys know that they've already picked that out. Now, what you guys need to consider is, okay, well, there's 6 remaining colors, and you have to pick 3 of them. And the 3 are the ones that we want, which are blue, indigo, and violet. So, what's the probability of picking a blue one when there's 6 remaining crayons? And it's 1 out of 6. So, out of the 6 remaining crayons, 1 out of 6 will allow you to get the blue one. That's the probability of picking a blue one out. Now, the next one, it says indigo, right? Well, we already picked out a blue one, right? Which means there's only 5 left in the bag, right? Or in the crayon box or whatever. So you need to pick, there's only 1 indigo out of the 5 now. Not 6, because 6 is when you was when you had the event blue. After you picked out a blue, then there's only 5 indigo left. And then you need violet. So, well, to get violet, the probability of picking out violet is 1 out of 4. Because you already picked out the blue one and you've already picked out the indigo one, which is why it's 1 out of 4. Multiply all this together, you guys should have gotten 1 out of 120, which is D, 0.833%. Okay, 14. Same deal. 11 different colored crayons, which includes 7 required colors, which is the rainbow colors. Red, orange, yellow, green. In the proper order, he forgets the last 3 colors. From the remaining 7 crayons, he chooses 3 at random to finish drawing the rainbow. Was it probably that he correctly finishes Roy G. Biv rainbow? So, again, this person needs to pick out blue, indigo, and violet, right? So, essentially, well, what's the probability of picking out a blue? 1 out of the remaining 7. Now, after you take out the blue, now you need to get indigo. So it'll be 1 out of 6. Because 1 out of 6, because you already picked out the blue one. And then violet, it'd be 1 out of the 5, because you already picked out blue and indigo. Multiply all those together, and I believe that you guys get 1 out of 210, which is going to be D. 15. So same deal for this one. There's 15 different colored and 7 required colors, which is the rainbow colors. You already got red, orange, yellow, and green, and he forgets the last 3 colors. Okay, so from the remaining 11 crayons, he chooses 3 at random to finish drawing the rainbow. Probability of Roy G. Biv rainbow. So there's 11 remaining, which means the probability of picking out blue out of those 11 is 1 out of 11. Probability of picking out indigo is 1 out of 10, because there's one less number because you already took out the blue. And then probability of picking out violet is 1 out of 9, because there's 2 less numbers in there because you already took out the blue and the indigo. So 11 times 10 times 9. 1 over 990, which is B. So that one's B. All right, 16. Now we're pivoting to another different types of problems, okay? All right, a technician is launching fireworks near the end of a show. If the remaining 14 fireworks, of the remaining 14 fireworks, 6 are blue and 8 are red. If she launches 8 of them in a random order, what's the probability as exactly 4 of them are blue ones? Okay, so this one is we have to figure out the total amount of choices, right? So do you guys see how 14 fireworks, there's 14 fireworks total, and 8 of them launches or is chosen at random. So that's your guys' total. So 14 total fireworks, and you're choosing 8 of them. Okay, this is combinations, okay? So 14 total fireworks, and you're choosing 8 of them. Now, we're going to get into the specifics. What is the probability that exactly 4 of them are blue ones? So the goal is to figure out what's the probability of picking out 4 blue ones. Well, first you have to consider how many blues are there in total. And there's 6, right? So 6, and you're out of the 6 blue ones, you want to choose exactly 4 of them. Now, didn't 8 fireworks get launched, right? It says in the problem 8 fireworks got launched. You want exactly 4 blue fireworks to be launched, right? Now, if you picked out exactly 4 blue ones, that automatically means you must have had also picked 4 red ones. So you guys have to account for your red ones, and I'll do a different color. So not only did you pick 4 exact blue ones, but you must have also have picked 4 red ones. So for the red, how many total red are there? There's 8. So 8 choosing 4. And that, you guys, will give you your probability. So when you guys do this problem, well, let me give you guys some tidbits. Do you guys notice anything about these numbers? So the total amount of fireworks should be equal to the total fireworks of each color, right? Do you guys see that? 8 plus 6 is 14. Also, let's look at your guys' choices. Well, do you guys notice that the amount of blue ones you chose and the amount of red ones you chose is equal to the total choices? Yeah, so that's how you guys know you can check your work on how you did it properly in regards to everything else. So when you guys put this into your guys' calculator, you should have gotten 16, part D. So you guys should have gotten around 34.965%, which is 0.34965. Yeah. All right. Now, if you really want to check your work, I could also do that for you guys. So let me quickly, I gotta get this down. So 6 choose 4, should have gotten 15. This is for you guys to check your work. And when you guys do 8 choose 4, you guys should have gotten 70. And when you guys got 14 choose 8, you guys should have gotten 3003. So this would have equaled 15 times 70, 1050 over 3003. And it would have been that. Okay. All right, next one. We got 17 now. All right, 17. So exact same thing, except now it's exactly 2 of them are blue ones. So let's start from the top. Technician is launching fireworks near the end of a show. Of the remaining 10 fireworks, okay, so I automatically know there's 10 fireworks in total. 4 are blue and 6 are red. If she launches 5 of them, so out of the 10 fireworks, she launches 5 of them, so which means you're choosing 5. Was it probably exactly 2 of them are blue ones? So exactly 2 of them are blue ones, right? So that means we need to choose 2 blue. Well, how many total blue fireworks are there? There's 4. So 4 total blue fireworks, and we're choosing 2 of them. But since we're choosing 2 blue fireworks and there was a total of 5 fireworks chosen, you also know that you must have picked 3 red fireworks. So that means you multiply by, well, you already chose 2 fireworks, and that means the rest must have been red fireworks. So 3. And how many total red fireworks were there? There was 6 that you could have chosen from. So put this into your guys' calculator on each one. So you guys should have gotten 4, choose 2, which is 6, times 6, choose 3, which is 20. Out of the total, 10, choose 5. And you guys should have gotten 252. So this is equal to 120 out of 252, which is around 120 divided by 252, 47.619%, which is A. Okay. 18. Same type of ordeal. So for this one, small pond contains 7 catfish and 5 bluegill. So that means I automatically know that there's going to be a total of 12 fish in total. And how many are we choosing? If 6 fish are caught. So 6 fish are caught. So out of the 12 fish, 6 fish are caught. That's the total. Now let's see what we're trying to solve for. Probability exactly 4 catfish have been caught. So you want to choose for catfish. Well, how many total catfish were there? There's a total of 7 catfish. So 7. Now, if you caught 4 catfish, that automatically means you must have caught 2 bluegill. Because, right, it says 6 fish are caught. You want 4 catfish. So if you catch 4 catfish, then that means you must catch 2 bluegill. So you want to catch 2 bluegill. And how many bluegill were there to start with? 5 of them. And if you guys notice, these are the same for me, which is good. And these are the same for me. They total the same thing, right? 4 plus 2 is 6, 7 plus 5 is 12. Alright, so time to put this in your guys' calculator. So, 7, choose 4. So we should have gotten 35 times 5, choose 2. Should have gotten 10. And 12, choose 6. Should have gotten 924. 350 out of 924, which means you guys roughly should have gotten, oh, no, 37.879%, which is going to be D. Okay. Alright, last one, you guys, alright? Alright, 19. Now, the only difference between 19 and 20, the difference between 19 and 20 with 16, 17, 18 is the last statement says at most and at least. So we'll read it again. A technician is launching fireworks near the end of a show. If the remaining 10 fireworks, 5 are blue, 5 are red. If he launches 6 of them in a random order, what's the probability that at most 3 of them are blue ones? Okay? So the key term right here, you guys, is at most, right? So this is how you guys go about it. Well, let's write down the total amount of fireworks there are and how many he chose. So there's a total of 10 fireworks remaining, and he decides to launch a total of 6 of them. Okay, so what's the probability that at most 3 of them are blue ones? So at most, you guys, means, well, he could launch however many, but it has to be 3 or less. That's what at most means, 3 or less. So let's calculate this. So what's the probability that he launched? Remember, at most 3 means 3 or less. So let's start from the top. So if he launched 3 of them, of the blue ones, how many blue ones total were there? There was 5 of them, right? But if he only launched 3 blue ones, that means he must have launched 3 red ones. So multiply by 3 red ones, but how many reds are total? 5 of them. So that's one probability. Now, remember, at most means 3 or less. So 3 blue ones or less than 3 blue. So that means we need to account for if he launched 2 blue ones. So rewriting this still. So now, if he launched 2 blue ones, there's still 5 blues, right? If he only launched 2 blues, that means he must have launched 4 red ones. Okay, continuing on, total. Now, this scenario, if he launched 3 blue and 3 red. This scenario, if he launched 2 blue and 4 red, now we need to do another case where if he launches 1 blue, that means he launched 5 red. Now, that's where you guys stop. And the reason being is, if you guys did a 4th case, you would realize, oh, okay, so what happens if he launched 0 blues? Then that means it forces him to launch 6 red. Now the problem is, do you guys see that? Do you guys see how he launched 6 red, but wasn't there only 5 red to begin with? So this one's not possible. Which is why you guys have to stop at him launching 1 blue. Then you guys just have to calculate all of this. So 5 choose 3. 5 choose 3. So this one's going to be 10 times 10 all over 10 choose 6, you guys, is 210. So that 5 choose 2. 10 times 5 choose 4. 5 out of 210 plus 5 choose 1, which is 5, times 5 choose 5, which is 1. Add all these together so you guys get 100 out of 210, 50 out of 210, 5 out of 210, which simplifies to 155 all over 210, which is roughly 155 divided by 120. Oh, 155 divided by 210, which is roughly 73.81%. And that's going to be A. Okay? So that's for 19. Okay, now we're going to tackle 20, and this is our last problem. Okay, so for this one, it's the same type of ordeal as the last one, but now it says at least. So a bag contains 7 real diamonds and 8 fake diamonds. If 6 diamonds are packed from the bag at random, what's the probability that at least 2 of them are real? So how many diamonds are there total? That's what you need to figure out, right? So there's 15 diamonds in total. Now it says probably that at least 2 of them are real. So at least 2 of them are real, and you're picking out 6 diamonds, right? So at least 2 of them are real, which means it could be 2, it could be 3, it could be 4, it could be all the way until there's no more real diamonds essentially left. So if 2 of them are real, well, how many of them total were real diamonds? 7 of them. So if you picked out 2 that are real, that means you need to have picked 4 that are not real out of the 8. So that's the scenario if you pick 2 real ones. Now we need to do the scenario when you do three real ones. So if you picked out 3 real diamonds, that means you must have picked out 3 fake diamonds out of the 8 total, right? Then you need to account for when you picked out 4 real diamonds. So if you picked out 4 real diamonds, that means you must have picked out 2 fake diamonds. Continuing on, right? Now you need to do the scenario when you picked out 5 real diamonds, which means you picked out a total of only 1 fake diamond. And lastly, you could do, if you chose all of them are 6 real diamonds, and then you've picked out 0 fake diamonds. You cannot go past this because, right, they picked 6 diamonds out. And if you picked out 6 real ones, you can't go past, you can't pick 7 diamonds if they told you guys to pick only 6, right? So here's this lovely creation. And now gotta crunch numbers and put this into your guys' calculator. This is why this is the last problem. So 7 choose 2. 21 times 8 choose 4. So that's 70. All out of 15 choose 6, which is 5,005. Plus, now we're going to do the next one. 7 choose 3, which is 35, times 8 choose 3, which is 56, all over 5,005. 7 choose 4, 35, times 8 choose 2, 28, all over 5,005. Continuing on, 7 choose 5, 21, times 8 choose 1, 8. And then lastly, 7 choose 6, which is 7, times 8 choose 0, which is 1. So we have to add all these together. So 21 times 70, 1470 out of 5,005, plus 35 times 56, 1960 all over 5,005. 35 times 28, 980 divided by 5,005. 21 times 8, 168 divided by 5,005, and 7 over 5,005. So add all of these together, and we get 4,588 all over 5,005, which is roughly 91.61%, or 0.608%. And you should have gotten D. All right, so that's it. So depending on your period, your quiz will be on a different day. So good luck to everyone, okay?